Hi, welcome to the Next Generation YouTube channel. Today we will learn what is 5G throughput and how to calculate, how to formulate 5G throughput inside the Python. So let's start with the basic. Like we know the information that travel inside the 4G and 5G on your frame only, right? So let's have a quick brief of what is frame and how it is work. Like in the 4G, we are having a radio frame of length 10 millisecond. Each frame is divided in 10 equal part from 0 to 9, and equal part we divide in 10 part. It is called subframe. So in each subframe is of 1 millisecond. Now I'm talking about the 4G is of 1 millisecond now, and each subframe is divided in two part. It is called slot, and each slot is of length 0.5 millisecond. So there is two slot inside one subframe. In each of the slot there are 7 OFDMA symbol from 0 to 6. So the in one frame we can say there are 10 subframe and there are 20 slot, right? It is simple. This is about only your time domain. This is your time. Okay, now let's get into the frequency one. Okay, so this length, this is called subcarrier. So total subcarrier in 4G were 12, and each subcarrier is of 15 kilohertz. Okay, so total subcarrier will be 180 kilohertz. So this become 180 kilohertz. Okay, so in 4G the subframe slot and a subcarrier were a fixed quantity. It's a fixed variable. We cannot change. So 4G frame was very simple, but now in the 5G, what is changed now? Since we are into the 5G with the big spectrum, with a very high bandwidth, the frame got changed in the 5G. Let's have a discussion on 5G frame, like how it work. In 5G only, we are going to have a one frame. A frame length will be a 10 millisecond, and the number of the subcarrier will be remain same of 12, but the length of the each subframe will get changed. Now in 4G it was only 15 kilohertz, but in 5G we are going to have 15 kilohertz. See here, 15 kilohertz, 30 kilohertz, 60 kilohertz, 120 kilohertz, or to 40 kilohertz. Okay, like that we are going to have in the 5G. So let's see how it's work in 5G. Now there is a one radio frame, each of length of 10 millisecond. Now the radio frame, if we are having a 15 kilohertz of subcarrier spacing, okay, so one thing is there inside a 5G. It is called numerology, mu. Let's suppose if you are having mu equal to 0, then your subcarrier will be 15 kilohertz. Subcarrier spacing will be 15 kilohertz. Okay, number of the subcarrier you are having, it will be at 12. So the length total will be this one will be 12. Okay, so now in here in numerology 0, 1, your slot duration become 1 millisecond. So if you divide this into 10 part, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, these are the equal part. So all equal part of 1 millisecond is equal to one subframe that we have already seen in the 4G. Okay, but if you are having a numerology 0, mu equal to 0, then you are going to have a subcarrier spacing of 15 kilohertz. Number of subcarrier will remain same. then your one subframe of equal to 1 millisecond, and into the numerology 0, it will become equal to slot. So you are going to have 10 slot inside one radio frame of 10 millisecond. Understood? Let's take second example. Let's take. So I am having I am having here, let's see. I am having here, let's suppose I am having numerology mu equal to 1. Here in the mu equal to 1, I am going to have a number of slot. This one, see here, number of slot is of length 0.5 millisecond. So there will be a 20 slot into it. Okay, because the radio frame remains same of 10 millisecond, the number of slot now become 20 slots, because I am having one slot of 0.5 millisecond, so there will be a 20 slot in 10 millisecond. Okay, now let's see here. I am going to have 12 subcarrier, but subcarrier spacing will become now 30. So this will become 360 kilohertz. Understood? This will become 360 kilohertz. As soon as I am going to increase my numerology to 2, I have now my subcarrier spacing 60, number of subcarrier will remain same 12. So you can see let's have one analogy. If you are having a one balloon here, okay, one balloon here on x axis and y axis. Balloon, let's suppose balloon is placed like that, like this only, here and here. If you start pressing this balloon but keep number of air inside the balloon, our amount of the air inside the balloon is same, then your balloon will be start compressing here, but it will be start flattening here on more here. Then again you compress it, start more here, again it will start. Even though if the length along the x-axis become less, the y-axis is keep on increasing. See, like this only, like I am going to have a number of slot is keep going on increasing, like from one slot per subframe, 2 slot per subframe, 4 slot per subframe, 8 slot per subframe. It is going keep on increasing, like 10, 20, 40, 80, 160, 320, 640. Okay, but the number of the slot inside, number of the symbol inside the slot, in this slot are remain same. Always there will be a 14 symbol. Okay, that we have seen into the 4G, it was 7 symbol. Okay, so it is same. So the air inside the balloon is same. This is, let's suppose this is the air inside the balloon is same. Okay, but you are keep on compressing it, then your balloon will become flat, become more here on the y-axis, like that. You can see here, you can correlate the size of your frame reducing along the x-axis, but it is increasing on y-axis. Let's see here. Okay, now let's go forward. Let's see more examples, like how it is working. Okay, now the similar we have seen here in the first slide. Let's have some view. This this context we have taken from the one of the famous website, like SciTech Notes. So when your numerology is 0, it is 0. At that time your slots of frame is 10, symbol remain 14, number of subframe is equal to 1. Let's see here, like you are having a 10 millisecond of radio frame, 10 subframe having 10 slot of 10 millisecond. Then each of the subframe is equal to number of slot is equal to 1 millisecond. So there will be a 14 OFDMA symbol inside 1 millisecond. Okay, inside 1 millisecond, like it is written here, and your subcarrier spacing is 15. Now if you are having a numerology 1, Now let's have a visualize numerology 1. You are having slot inside, symbol inside slot will be 14. Your slot become 20. Okay, see here, one radio frame, 10 subframe, 20 slot in 10 millisecond. Now one subframe is, now it's become 2. Here it was 1 only. Here it was 1 in 1 millisecond. And see here, one slot, in one slot there will constant 14 symbol that we have already seen, but there will be a 2 slot now, one slot, 2 slot now. Here you were having only one slot in 1 millisecond, but here in 1 millisecond you are having 2 slot, each of length 0.5 millisecond. Okay, if you are having numerology equal to 2, see here, your radio from frame is 10 millisecond, we are going to have 40 slot in 10 millisecond. In one subframe there are 4 slot. Okay, there are 4 slot, and each slot is length of 0.25 millisecond. Again, if you are having numerology more, numerology equal to 3. Okay, see here, now you are going to have 8 slot in one subframe, each of length 0.125 millisecond. If we are going keep on going increasing, if I'm using numerology equal to 4, then inside 10 millisecond in one subframe I'm going to have 16 slot, but symbols remain same, 14 symbol. That's why the radio frame is length increase in y-axis, but and decreasing in x-axis, because we are reducing time from 1 millisecond to 0.5 millisecond to 1 to 5 millisecond, 0.1 to 5 millisecond, keep on increasing. 0.5, see, this is 0.25, this is 0.125, this is 0.0062. We are keep on decreasing the time, but a frequency is keep on increasing. Okay, let's check one more. Let's check take how your number of RB behaves based on your subcarrier selection and your based on your whatever the bandwidth you are using. Let's suppose, see here, this is the table from the 3GPP. Let's suppose you are having this table. Okay, you are having this table. Let's suppose you are using 30 kilohertz of subcarrier spacing, and your bandwidth is 100 megahertz. This is in 100 mega, it is in megahertz. Okay, you are having 100 megahertz, so your RB is equal to 273. Why it is 273? Let's calculate one mathematical one. Let's do one mathematical calculation. Suppose if your subcarrier spacing is 30, then you will going to have a 12 subcarrier. It is in kilohertz. Then it will become 360 kilohertz. Correct? Now your bandwidth is 100 megahertz. So your bandwidth is 100 megahertz. So take it is 100 megahertz divided by 360 kilohertz. This will become somewhere around 277. Okay, approximate. But during the our actual calculation, there will be some overhead. There will be some loss. So as per 3GPP, they are considered as 273 number. As 273. So by this table, what we are able to get, like when you are having a subcarrier of 30, means numerology equal to 1, at 100 megahertz you are going to have a 273 RB. Here in the 273 RB, suppose you are having the resource elements, your grid resource related. So you are having starting from 0, this is your 1 RB till 273 RB you are going to have. Okay, like so this table is for FR1 and this table is for FR2. When you are having subcarrier spacing 60, then you will going to have, if you are using 100 megahertz, you are going to have 132 RB. Why 132 RB? We have seen as soon as our subcarrier got increase, our length in the y-axis is keep on increasing. So it keep on increasing. So as soon as your subcarrier is increasing on same megahertz, same bandwidth, I am having less RB, but even I was having 273 RB, but here it is less RB. You can correlate here from the table only. Okay. Now let comes to the topic, the 5G throughput calculation. To calculate a throughput, we need some information like what is the frequency resource, how much the frequency resource we are using, a bit per symbol, efficiency of the channel, and time resource, and the parallel stream like the MIMO stream, whatever we are getting. So we are having a simple formula for the throughput calculation. I'm using a simple formula for throughput calculation. I'm not going as per the 3GPP in detail, because in detail the formula is it's complex, it's lots of complex. But I'm excluding some processing and some overriding part from it. It is a straight formula. Okay, it is not as accurate as 3GPP, but it is remain close to the 3GPP. Okay. Now, what is NRB? Number of resource block. So number of, we already check number of resource block is depend on which factor. It depend on bandwidth and subcarrier spacing. Here in the table, see, based on your bandwidth, based on your this one bandwidth, and based on your subcarrier spacing, you are deciding your number of RB. Okay, NRB, number of RB. So this will come from our table, from the combination of bandwidth and subcarrier spacing. Now 12 is my number of subcarrier. That will be fixed, that we have seen here into the table. Here we have seen, right here we have seen, like number of subcarrier will always remain same, 12. Next, now subcarrier is gone. Now QM is your modulation. What modulation you are using? If you are using a QPSK, then you are going to have a 2 bit per symbol. If you are using a 64 QAM, your 64 QAM, then it is 4 bit per symbol. Yeah, sorry, for 64 for which is 6 bit per symbol. If you are using a 16 QAM, it will become your 4 bit per symbol. And if you are using 256 QAM, then it will become 8 bit per symbol. Bit per symbol means what? Here you are having, here in example, okay, you are having constant symbol 14 in everywhere. So based on your modulation, if it is QPSK, you will have a 2 bit into this one symbol. If you are on 64 QAM, you will going to have 4 bit in one symbol. As soon as your modulation got increased, your carrying capacities of your symbol will get increased, and you will get a better throughput. Now let's move forward. Let's go to the R. What is the R here? Is the code rate. Code rate is always in between 0 to 1, and we always in practical we are got at 0.93. We got a better, a good, about a maximum efficiency. Okay, and next, N slot. So one is remaining, this one, the number of symbol per slot. So just we see number of symbol per slot will remain same, always 14. And now what is the N slot per second? Number of slot per second. So there is, let's understand how to calculate this number of slot per second. Here let's understand. Let's suppose you are having numerology equal to 1, and you are having your bandwidth is 100 megahertz, assume, and your subcarrier will be 30 kilohertz. Right now, in mu equal to 1, in 10 millisecond, you are going to have a 20 slot. Okay, So this denote is what? This denote number of slot per second. If you are transmitting 20 slot in 10 millisecond, then in 1 second how much slot you will transfer? Obvious, 200 slot you will transfer, right? Okay, so there is a one simplified formula that we are having is slot per second is always equal to 1000 into sub carrier spacing divided by 15 kilohertz. Okay, this is a simple formula. Let's put the value in the formula. Here 1000 remains always remains same. Sub carrier spacing is 30 kilohertz. This is your 15 kilohertz. So this will become 2. So 1000 into 2 will give 2000 value. So on, you can calculate for anything, any subcarrier spacing, whether you have 60, whether you have 120, you can calculate from this formula only. 100 into subcarrier spacing divided by 15 kilohertz. So we cover last one is layer. So layer means what? Number of layer used by MIMO or massive MIMO. If it is 2 by 2, 2 transmitter, 2 receiver, then value will 2. If it is 4 cross 4, then it is value will 4. We'll take the value as 2, value as 4. If it is so on, if it is 8 across 8, we will take 8. If it is 64 by 64, we will take 64. So now to calculate a 5G throughput, we need a number of RB, number of subcarrier, modulation, code rate, then number of symbol, then slot per second and layer. So let's formulate this all thing inside the Python. Let's take a input from the user and let's design a code, interactive code. Like every time you can give a value of your NRB and everything. Based on that you will get a based on that you will going to have a throughput, like how much throughput you will get on different combination. So let's go on our coding screen. So let's write formula first. I will mark down this line to write a formula. I am going to write a formula like whatever we have seen. So your throughput will be equal to what is equal to your NRB, number of resource block, into your 12 subcarrier, into your modulation, like what modulation you are using. Okay, next your coding rate, your R that we have seen. Next you are going to have a number of symbol per slot, then you are going to having a number of slot per second that we have seen in last. At last you are going to have a layers like MIMO layers. Okay, MIMO layers. So let's do coding, like how it will be look inside the Python. So let's start. We'll do by step. So let's start from step 1. I'll comment this line. Let's start from step 1. So let make it a interactive program, like user should input the value, and based on the value a user can able to get the required output. So what we required first is bandwidth. We require a bandwidth. Let's take a user input. So bandwidth will be always in integer form, right? So let's take a input from user. I'm taking an input from user. Okay, input from user, and what input I am taking from the user, like enter the bandwidth. Okay, right, we require a bandwidth, and bandwidth always in megahertz. Always try to write as much as possible, like if any other person is reading the code, he is able to know like what you have written here. See, like we'll use the parentheses, then we'll close the bracket. Second what we required is subcarrier spacing. Subcarrier spacing already we have seen, like so subcarrier spacing always will be a integer value. Input, I will ask my user to input. What input user will give? Enter the subcarrier spacing. So if you want, if you can give like how many types of subcarrier spacing is possible, like 15, 30, 60 and 120. Okay, so on multiple things are possible inside your inside your subcarrier spacing. So we have mentioned all of this, that is whatever is required from as per the 3GPP. Okay, so we'll close the bracket. Okay, next we'll take input. Now we have to check the modulation, what kind of modulation is using my channel is using. So modulation, modulation will be an integer. I will ask user to input what, the input the modulation. So enter the modulation, again. If you want, I can give like what is value in modulation. Like if there is 2, your channel is using QPSK modulation. Okay, if there is a 4, that means my channel is using QAM 16 QAM. Okay, so on. Like if my channel is using a 8, that is mean it is using 64 QAM, right? On a 6 it is using 64 QAM. If my channel is having a 8 value, then it is using 256 QAM. So on, you can write anything inside your parentheses if you want to write. Okay, but try to write a logical things once you are writing a code. Now what I want, other value are fixed. Now I want a code rate. What is code rate? Code rate. Now one thing you have to see, like code rate will be a decimal value. So for a decimal value, we are going to use a float function, float data type. What I will tell user, input your code rate. Okay, the code rate, what I will tell user, enter the code rate. Again I'll tell user example, because your code rate is your efficiency cannot be more than 100. So we are considering like you give the example, like put value between 0 to don't write like example, give example like the code rate is 93. Okay, so now again I will close the bracket. Now we are done with the bandwidth part, subcarrier spacing, modulation, code rate. Now we have to add up layers, like how many layers MIMO are using. Again, layer will be an integer number. Okay, so I will take input from user, enter the MIMO layer. Okay, so I will again write enter the MIMO layers here. So everything I have covered, like bandwidth, based on the bandwidth and subcarrier spacing, we are going to having an NBR, like we have seen, number of your number of resource block, NRB, it should be NRB. Okay, it should be NRB, number of resource block, then modulation, then code rate. Now once it is done, let's check, let's assign everything. See, now it is asking what, asking bandwidth is 100. Now subcarrier spacing, I'm taking a 30. Now give your modulation, it is 6. Now your efficiency, I'm considering the maximum efficiency of the channel is 93. Now enter the MIMO layer, I'm entering the MIMO layer, it is 4. I'm giving a 4 MIMO layer. Okay, you can one more thing you can write here, like MIMO, if you are giving a MIMO layer, write an example like how much many MIMO layers you can, 2, 4, 8. Okay, like that you can write to make a program interactive. Let's say it's 100, it is 30, it is 8 again. My MIMO, it is asking 0.93 I'm assuming. Now it is, let's say MIMO layer is 4. Okay, that's it. Now we have assigned everything value. Now let's see, let's go on second step number second. I'll just comment this one. Okay, let me show you one thing, like 5G throughput calculation, share take note. Okay, if I go here, see, we have to import this table inside your Python. At what subcarrier spacing, along with the bandwidth, how much RB you are going to be have. like we have seen for 30 kilohertz and with 100 megahertz of bandwidth, you are going to 843 of RB. Okay, like that we have to go we have no see this figure for 30 kilohertz, 100 megahertz of your channel bandwidth, you are going to have a 273 of RB. Okay, see this here 273 of RB. Now let's formulate this one. Let's go inside our Python, and now we have to calculate a RB table. So give your, and I'm giving one name is NRB table. Okay, NRB table. Now I will going to use a nested dictionary. Nested dictionary I'm going to use, that is 15, not 15. See here, if I check, now I have to input subcarrier spacing. Okay, subcarrier spacing, it is 50, 30, 60, 120, 240 and so on. I'm going to use a going to have a subcarrier spacing. Now I'm importing this table into the my Python by using nested dictionary. So let's suppose your subcarrier spacing is 15. Okay, for the subcarrier spacing of the 15, now if you are having a bandwidth of 5, then what will be your number of RB? It is 25, right? From this table it is 25, 52, 79, 108, so on you are going to have, right? So now if you are having, if you are having a bandwidth of 10, okay, then how much RB you are going to have? It is 52. Okay, from that table we have to write. Okay, I'll just copy this one, I'll just paste. So now show on, if it is 20, then how much it is? It will be a 106. It will be a 106. Now let's add some more things, like if it is 20 is done. Now it is 50. If it is 50, then how much it will be? It will be at around 270, I think. It will be around 270 for the 15 kilohertz. Okay, for 50 it is 270, right? It is 270. Let's not import everything. I'm going to import some of the things, otherwise video will become so long. Okay, now if it's 30, let's copy this one. No, don't no, okay, if it's 30. Okay, so for 5 megahertz of bandwidth, how much RB you are going to have? It is 11 from that table. Okay, for 10 megahertz of spectrum, for 10 megahertz of bandwidth, we are going to have 24. Okay, let's see, 24, 38, 51, 60, 78, so on. Okay, let's write, let's have some value only. Okay, for now we have done with the 10. Let's check one more value and one more value. 10 we have done. After 10 let's check 20. After 10 let's check 20. For 20 we are going to have a 51 also. 51 here, I think it is 51. Yeah, it is 51. For 20 it is 51. Then we'll take 40. 40 it will become 106. And then for your 100, let's check 100. Like 100 we are using, lost of the operator are using nowadays, so it is, let's check 100 is 273. Okay, let's close the bracket, and let's take an inventor. Now I'll copy this line only. Copy this line. I'm going to paste this line here first, and one more line I'm going to paste here. Okay, let's take for 60 and let's take for 120. Okay, so 60 will start from 10. So let's do for 60. There will be no 5. It will start from 10 only. So 10. For in 60, for 10 you are going to have a 11 RB. Yeah, for the 20 you are going to have a 24 RB. For 40 you are going to have a 51 RB. And for 100 you are going to have around 153 RB. Okay, see here in the, for 5 it is 11, for 10 is 24, for 20 is 51, for 40 is 105, 10, 21, 10, 24, 40, 51, 100, 153. Okay, let's check. See, it is very simple. As soon as your subcarrier spacing was increasing, see, your number of RBs are shifting. Okay, it is now, see here, it is become half, it is become half, it is become half, it is become half, it is start shifting. Okay, for 150, for 120, 120 start with, I think 120 start with 50, 120 already started with only 50 megahertz. Okay, so let adds 150, 50. For the 50 RB we are going to have a 30, for the 50 subscribers we have 30 RB. For let's take direct 100. For 100 we are going to have a 66, we are going to have a 66. For 200 we are going to have somewhere around 132, and for 400 we are going to have around your 264. 264, let's check one more time. I will add this one also, this one only, I will not add more than that. Let's take 32, 66, 132, 264, 32, 66, 66, 132, 264, 66, 132, 264. For 50 it is 32. Okay, it will be that. Okay, let's 32, 66, 200, 132, and 400, 264. Okay, let's run this our next state dictionary here. Remove the space. Okay, we have assigned this one. Okay, we have assigned the NR table, the 3GB NR table. Now let's take a step number 3. Now step number 3 will take, now take a RB from it. Get now we have to get the NRB value from here. Take number of RB, how we will get from the bandwidth, and the subscriber space, on which bandwidth, on which subscriber spacing, what number of RB we are having here. From here, like which subscriber spacing, on which bandwidth, number of RB, like we have imported here. On your, this is your bandwidth, this is your subcarrier spacing, and this is your number of RBs. This is your bandwidth, this is your subcarrier spacing, this is your number of RB. Okay, now get the NRB value. Now I'll use one function, I will use one augmentation. It is like try try to get a NRB value. Okay, from where? From NRB table that we have created here. Okay, this table that we have created here from NRB table. NRB table, what you are going to have, what you are going to get from the NRB table, at what subcarrier spacing, with at what bandwidth, at what subcarrier spacing, and what at what bandwidth you are going to have the your number of RB inside it. So I have taking the number of RB from this table. So print. Now I will use a nested print here. So print now. What I have to print is, now I have to print, I'll print the next line, like this is the number of RB. It is we are imported from 3GPP table to, you can write it is from 3GPP table. Okay, this is the 3GPP table. Okay, table, this is the 3GPP table. Okay, from the 3GPP table we will import that one. Okay, and what we will say, give me the value of number of RB from the respective subcarrier spacing and bandwidth that that user are going to be select from this 100 and 30. Which one is there? For the your 30 and 100, it should select 273. Okay, so that value come here, and that value I am taking as a NRB. Okay, that value I am taking as a NRB. Close this one. Now if there is an error, except if see, I haven't entered the whole value here. Now I'm because if entering start entering the whole value here, it will take lots of time to enter all the values here, like for both FR1 and FR2 we have entered selected values. Okay, except if it is not meeting a criteria, then accept your key, because key error, see, we are giving a key. Dictionary is in the key value form, but now we are using nested dictionary. Dictionary inside a dictionary. Okay. If you want to learn more, then you can go to our courses and you can check over there. If you want anything more to learn. Okay. Now, if it is not there, that pair is not there inside that one, then print. You can say anything. Invalid bandwidth and subcarrier spacing combination. You can write anything. I'm writing invalid and sub combination. Let's run this code. Okay, see, it's picked 273 from here. It's picked 273 from here. Okay. Now there are some fixed value like number of subcarrier and number of slot that we have seen already in the theory part. So in step 4, let's add fixed value like a subcarrier. Subcarrier is equal to 12. It is fixed. Okay. So and number of symbol per slot will be the also fixed, right? It will be 14 like we have seen. Symbol per slot, how much it will be? It will be 14. I'm just assigned like if I ask you to give a subcarrier, give me a 12 number. If I ask you to give me the number of symbol per slot, give me the symbol per slot and give me the 14 value. Okay, I have assigned this one. Now let's write one more thing like in step 4 only, like slot, like we want here in the formulas we want a slot per second. Okay, that we have calculated by the formula 1000 multiplied by subcarrier spacing divided by 15 kilohertz. Okay, that we have calculated. So now let's calculate a slot per second. It is based on subcarrier spacing. Okay, this will take from the subcarrier spacing only. Now I'm giving one if else. I'm using one if else function here. If my subcarrier spacing, this subcarrier spacing, if my subcarrier spacing is equal to 15, okay, if it is equal to 15, then print. Do not print. Then my slot per second will be. Then my plot per second we have seen already, right? 1000. Okay, let's remind you again. We have seen like 1000 multiplied by your subcarrier spacing divided by 15 kilohertz. We have seen in our theory part. Okay, this formula we have used. If it is not there, then use a if else function. If it is not, so subcarrier spacing if it is equal to 30, let's say if equal to 30, then my slot per second, give me a slot per second as 2000. Okay, we have seen in the calculation part. Else if, let's see, if it is 40, it should not be 40, it will be 60 now. If 60, then it will become 4000. If 120, it will become 8000. Correct, 8000 it will become. Now else, if nothing is there, if nothing else, will start from here. If nothing is there, then write slot per second is equal to 0. So I have assigned this one, right? Now if I print in this scenario, my slot per second it will become 2000 because I'm using combination of 130. On 130 it should be 2000. As expected, we got 2000 here. Okay, now let's formulate our 5G throughput. Step 6. Step 6 will formulate everything. They will step 6 for formulate the 5G throughput formula and Python. Okay. So let's give one example. Like I'm giving a one variable throughput. Let's it will be become it will comes in a bit per second. Then we'll convert into the later on part. Now what I want is I want an RB. This I want an RB. It is in my formula, right? I want an RB. An RB in multiplication with an RB. I want subcarriers. This subcarrier I want subcarrier. Then what I want is modulation. Then I want modulation. Your modulation will be here. Modulation. Okay. Then what I want is after modulation there will be a code rate. Code rate I want. Okay. Code rate I want. Then after code rate I should have slot symbol per slot. Symbol plus slot we have written here. Symbol plus slot should be here only. It is one. This one is symbol per slot. It will be always 14. Symbol per slot. Symbol per slot. Then I want a layer, a MIMO layer. I want a MIMO layer from here. See, let's check again. I want NRB, subcarrier spacing, modulation, code rate, slot per symbol, and layer. Let's print this one. Okay. Now I want to check the 5G throughput in bit per second. Now, so 5G throughput in bit per second. Let's check how much we got. It is in bit per second. Now let's convert a bit per second to the throughput in your Mbps. It is now I'll write here. Sorry. Now I want throughput is Mbps. It is very simple to convert in Mbps. Your bit per second. Then it should be a divide by 1 to the power of 10 to the power of 6. Then print your Mbps. Now let's see it is becoming Mbps. Something is on in here. I think something 1 2 3 4 5 6 something is missing. NRB into subcarrier, into modulation, into code rate, into symbol. Okay, into symbol we have missed here the slot per second. It should be a slot per second. Here we will take slot per second. Okay, we have missed the slot per second. That's why the value is coming so low, low throughput. See, now you got the throughput of 2729. Now let's make a interactive one. I'll take one other notebook. Here I have taken the 1 by 1 code. Now I'll combine all code into the one, and let's see how it is working. Okay, let's see how it is working. This will become we have write the code step by step because to debug error easily. Now we are writing all code Let's see how it is, look, let's see. Okay, let's run the code. Your bandwidth is 100, example, subcarrier spacing 30, modulation I am taking 56 QAM, efficiency I am taking maximum, MIMO layer I am taking 8, the throughput is 5459. Okay, your NRB is 273, your throughput is this much. One more thing you can use here in the, see, this is the throughput that we are getting theoretically, but in real form there will be some overhead. So let's give a real throughput, like how much you are probably able to get in the real scenario. So throughput we are considering 86% to be we are going to have in the real type. So now print what you are going to print. You are going to print your real throughput. Okay, let's say now 100, subcarrier 30, QAM I'm using 8, your it is become 93 efficiency I'm taking, MIMO layer 8, it is 54, like that you are going to have. Okay, so if you have any doubt related to the content what we have provided now, kindly comment it down. And if you want to learn more from next gen range solution, kindly use our WhatsApp group from below shared link. There we will teach you like how to use more Python into the telecom, how to model your report, how to learn machine learning, how to automate your report, everything that are required in current industry trend. So join us, and again thank you.